All right, solving with nth roots. Think about something with me for just a minute. We just did this. This should come very easy for you.
What is this?
We had something that looked close to this. And actually, let me even make it a little easier. Let me make it 25.
Cheating.
If you need to solve that for x,
It's 5.
what do? You
You square root it.
You square root it. And yesterday we learned that a square root has what as an imaginary number sitting out here? 2, right? Do you see why now we use square root?
Yes.
You see the 2 and the 2?
Because they cancel each other out.
They cancel each other out. So we said before that a squared and a square root are opposite operations. What though if this were x to the third equals 27?
You do the form when you do the x plus 3 and then the x.
You cube root it. You third root it. You put the 3 out here. And you do that root on both sides. So it's 3.
So could it be 4 and so on?
Do we need to write this?
Yes, this is the lesson.
Could it be like 4?
It could. So whatever the exponent is, so to cancel an exponent,
You're lying.
take that root. Just make sure those numbers are the same. We'll pause a second. All right, so let's say I have 1/2 x to the 5th equals 512.
1/2 x to the 5th. Oh, what? Oh, good.
Okay. Now, how many times do you see x written in that problem?
Third, 5. Wait, what?
1. It's just written one time, though, right? It might have an exponent, but it's just written once. And any time we see x written one time, okay?
Hey, just one time.
We sad map our way out of it.
Hey, hold up. 8 to the 3rd, 512. 64 times 8 is 512, correct?
I don't know.
So we multiply.
So, with the first thing we do, you're right, Phoenix, we multiply because there's no addition, subtraction. There is multiplication, division, which is here. And to get rid of that 1/2, we do what?
Oh, I was right.
Multiply by what?
The flip.
The flip. So that's gone.
You get 1024.
All right, so you get 1024. Now comes the new part. Somebody said we've done this, and we have, but we've done it with exponents of 2. Now we've got an exponent bigger than 2. So now the question is, how do I get rid of this?
So what times you sell 5 times?
You do, but write it in the problem. Not square root, but
I know this one.
5th root.
Say what?
5th root.
So you say like the number side.
Correct.
So it's root and whatever number it is.
Right. So the key is that these two have to match to get them to cancel.
What 5 times equals 1024?
I would definitely probably use my calculator. It's 4.
Yeah.
Here's
How did you get 4?
16 times 4 is 64.
what times itself 5 times. So math 5, the 5th root of 1024, or 1024 to the 1/5. Yes, you can.
What's 64 times 4?
Can
we do it on that's not a fraction?
What you mean a fraction?
It's the same thing, bro.
All right, wait, before we move on, before we do anything else, do I need a plus or a minus here?
Yes. No, it's an odd number.
Luther, put that away.
Your 5th root's an odd number.
Your 5th root's an odd, it keeps the same sign that's under the radical. Does that make sense?
Can we do one that's not
Wait, so this odd and you don't know what's there, but even.
When you multiply by 2 here, 512 times 2 is 1024. All right, let's do another one. Let's do 3x squared 108. Okay? Now this goes back to chapter 1, so this should really be easy for you. I see x one time, so I'm going to sad map my way. Yes, absolutely. So the first thing I'm going to do is divide by 3. Don't take the root right now because the root's only hooked to the x. Yes. 3 goes into 108 how many times? All right, hold on. Let's let everybody catch up with us. Okay? Now what? Second root, which is just a regular old, plain old square root. And we know that the plain old square root of 36 is close. Plus or minus because it is an even root. Okay?
Wait. I'm going to Cash C.
Gil, guys, I need y'all to
We're
focus.
still recording, by the way.
I know. One more. Try this one on your own.
I really wasn't done with the last one.
All right, guys.
There are no real roots.
Sad map.
Oh, I got it now. I don't see why you couldn't combine 2 and 5.
No,
Because X is only written one time.
What does that mean?
Even though there's an exponent on the outside, it's only written one time. DeAndre,
You talking to me?
you better be writing every bit of this down.
He is, I swear.
Are you talking to me?
No.
Why can't you combine the 5 and the 2?
Why you get all my friends back?
Because first what you have to do, the fourth root of 16 is plus or minus 2.
Put it in right terms.
So you could combine the two. If you think about what this means, when you subtract 5,
You get negative 3.
one of them, if you did positive 2 minus 5, you'd get negative 3. But what about if you did negative 2 minus
Negative
5?
7.
Right.
So I could put both answers?
Yes, yeah. I didn't see you say negative 7. I'm sorry. Yes, this goes back to chapter 1 when we were doing this.
That's acceptable.
Yep. This example. Well, maybe. Let's see. This one you're gonna have. This one's gonna be a little bit harder for a couple of reasons. Negative's one thing that's different about it,
Really, Miss McGee?
but there's something else that's different here.
Parentheses.
There's a negative. What else though? What else? When you go to solve this, what's the first thing you're gonna do?
You're gonna cancel out the 3 on that.
By doing what?
The left side.
Square root of negative, so you have to.
You can't square root a negative, but can you cube root a negative?
Yeah, you can.
So it don't cancel.
Is there any number that multiplies by itself 3 times to give you negative 14?
No.
So I have to pull out my handy dandy calculator.
Uh-oh.
And I have to say, the third root, so 3 math 5 of negative, negative 14. Or, if your calculator doesn't do nth roots like this, remember I can always do negative 14 raised to the what? Parenthesis 1/3. I can sunshine it.
1/3.
This one's just negative. That's a good point, Phoenix. I don't need the plus or the minus here because it's not an even root. It's an odd root. So I just do negative 2.41. And don't forget that it's not solved yet.
You have to add.
I got to add that too, right?
Yep, so it'll be 0.41.
Negative. I'm going to say approximately negative 0.4. Refresh your memory on of what? A perfect root?
How do you know, like, it's
Plus or minus are even roots. Odd roots keep the same sign.
Squiggle the equal sign.
That means approximately, because I rounded it. If you estimate, if you round. One more like that?
So we wouldn't break.
No, I don't know how to put it in my calculator.
We wouldn't break.
Are we gonna get one of those like that?
No.
I'll think about it.
Yes, Lily, you will. I was answering Tyler. Look at this one. Look at this one. 2 times x minus 8 to the 5th equals 100.
You have to multiply two. You have to divide.
Divide by 2 first, right? Because parentheses and exponents, those are last. So I need to take care of everything that sits outside of them first.
So it's minus 2.
Not minus, but
Divide by.
divide by, because this is multiplication there. All right, so I got x minus 8 to the 5th.
And it's basically just a problem that we already done.
Now it looks yes.
But you're still gonna put it out outside the box.
Exactly. Now you're still going to have to do the 5th root.
Because it's not.
And I'm back to the point of, I don't know of a number that multiplies by itself 5 times to give me 50.
Get the calculator.
Students, 2 is not.
1.3789.
Yeah, no. So I got to get the calculator back out. If you're an nth root calculator, I would do 5, math 5, 50. If you don't have that capability on your calculator, if you have the little TIs, then it's 50 raised to, parenthesis, what's the exponent? 1 over 5. 2.19 approximately. Am I done?
Nope, subtract 8. Or add 8.
Add 8, that's right. We still got to isolate that x. Dwight.
I don't understand how to put this in the calculator.
All right, which part? The root or the, what kind of calculator do you have? A graphing one? No. Okay, so you're going to have to put it in as an exponent.
So it'll be 50.
So see the last one I did 50 and then I raised it to the power. I basically sunshined it. I took this 50, this, and I changed it to this. Yeah, for the calculator. And that's what I put in here.
So if the 5 is on the outside, it has to go
I mean,
on
I
the
get it,
inside.
how to do it, I just don't understand how to put it inside the calculator. That's what I mean. I wasn't paying attention to it. Sorry.